Okay, so it has to be really your work. You can just make a website through even the Microsoft Word, save it as a HTML, but you deploy it on the public website. And when I say this, it should be accessible from anyone in the network. So you have to make sure that the access permission is for the public. So TA, when he plays, he's gonna click on the link, right? So that's all the part of the assignment. Don't just say, oh, I uploaded HTML file on a public cloud. That doesn't mean that it is deployed publicly accessible website. Questions? And you're gonna have a quiz as well today. Again, open book, open note, please. Yes.
We received a $50 GCP coupon on our mails.
Oh, right, yeah. So everybody.
So, should we redeem it? Like, what is that about?
Oh, you have to redeem it ASAP.
All right.
Yeah. So but make sure you also have a free credit from AWS, Azure, and GCP as well. That the $50 is just small additional one. I think free credit is a 200, 300, right? So when you have a new account, theoretically, you can use multiple emails and have a multiple, the free credit. That's possible. It's a kind of trick. But for $50, you have to use UMKC.edu or umsystem.edu, just one per person. Don't use two, because the number is just about the same as the now more of the settled enrollment, right? So, So I know that it works. TA, when we send it out, I also check with TA and it worked. So that email actually comes from GCP, Google Cloud Education Grant, and it says that you have to redeem it by do it ASAP, right? And it says that it's available for a year, but you probably will use it up a lot earlier. So yeah, thanks for bringing it up. Any other questions?
I have a question. What is that used for? Like, I didn't understand what.
Oh, these credits for doing assignments and projects.
Okay.
Project. So from assignment 2, it's a hands-on assignment. We focus on the behind the scene, but in parallel, we also, have some, front end the experience with the public clouds. Okay. Right. And then later there will be a term project, that from the syllabus. So up to, I think this one maybe it could be actually 3, but maybe it should be okay for up to 4 people. You can do it by yourself. There will be a project. That's something that you define on your own. You want to have if you have a new startup idea, that's okay as well. Open data analysis, visualization, that's okay. Building a cloud from scratch, that's also a good one as well. Later, I'm gonna give you a list of the previous students' work. So later, actually, since you brought that up, all your work, know that it will be passed down to the next semester students, right? So not just for the grading, you want to do something that you want to feel proud of. So the assignment is just a small, like me pushing you, you should try this, try that. Project is really self-motivated, can be really in-depth work. Right? So for that, that's one of the way for you to interact with your classmates. So in the accountability group, right? Initially, you will be assigned with the random group of people in a group. Um, you know, if you find the classmate is really doing well and you want to work with him or her for the project, you can do that. Or if you want to find someone else, that's also possible later. So we're going to have the accountability group twice, first quarter, second quarter. Other questions? These questions helps other students too. Oh, that's the question I had too. So what do you recall from last time? Oh,
History.
so let's see, students sitting in the last row, right? That four students. Tell me, five students. Tell me what do you recall from last time? Here's a hint. Okay. Just tell me any word. Oh, we talked about cloud computing. Be more specific. Opinion. What's it? Question is, can you tell me any word or anything that you remember from the last class? Multi-tenancy. Okay. Yeah. Okay. All right. Video of what video did you watch?
How the cloud computing is
Okay. Anyone can tell what was the who made the video?
We were talking about the history of cloud computing last class.
Right. Who made the video? Salesforce. So it's actually industrial company Salesforce's video promoting their service product, right? Yeah. Good. And other next student. Hiding behind the screen. It's like, tell me just anything from last class. I'm sorry? Oh, you wasn't present. Okay. I mean, you can take a look at the picture. You can say, Amazon founder. Or, abracadabra, cadabra, right? What's that? Oh, you were asking. But anyway, welcome to come to the class. Okay. Characteristics of cloud computing, inside cloud. Right, yeah. Good, thank you. So today we're gonna, in the quiz there are questions on, we also talked about the trend actually earlier. The quiz is about the trend as well. I don't think we talked about this yet, right? Related computing models. So this is where we are going to do. So in cloud computing definition, some of the definition you saw from Wiki was that it's a model of computing, blah blah blah, right? There has been many computing models before and after. What computing models you have heard of? I'm sorry? Distributed computing. It says related, even if it's not related. Have you heard of some computing?
Cluster-based.
What's it?
Parallel computing.
Parallel computing, right?
Cluster-based.
What's it?
Cluster.
Cluster computing. Distributed computing. Grid computing, right?
It's quantum.
What's it? Quantum computing, right? So I think we had some of the questions here before. the relating to particularly cloud computing, these are the related computing models. So really different from local computing. We are using more than one computers to do something, and these are examples. Utility computing is different concept. Did we talk about all this? No, not really, right? So I want you to at least to be able to distinguish there are certainly overlaps in terms of technologies. It's not like here's a cluster computing technology ABC that can help really cluster computing, and it's a completely different set of technology that is for cloud computing. That's not the case. So it's certainly related, but when we say these terms, they are focusing on some aspect, and I want you to be able to tell and explain, okay? What are the similarities? What are the differences? So, first of all, cluster computing. So here keyword is a cluster, first of all, right? Cluster meaning more than one, right? They should be connected together over a network. And that network is what? Can you read this please?
LAN.
LAN. Yeah. That stands for Local Area Network. If it's not LAN, what other network do you? What's it? WAN. Wide area network. Basically, broad the internet, right? So LAN is a local area network, like one network that doesn't. So theoretically speaking, it doesn't go through a router. Okay, layer 2, the connectivity. That's what the LAN means. So the connecting device would be switch, not a router. UMKC network is a LAN. UMKC, we do have a router, but that goes to the outside of the UMKC. We have more than one router for redundancy. But within the campus, our focus is not like a shortest path, whether to go this path or that path, to have a shorter path. That's not the focus. Local area network, our main focus is just connectivity without a loop, So just the connectivity. We need to have we don't need a routing optimal path thinking intelligence for the when. We just need all these devices need to be connected. It's not too huge. Theoretically, you might say, all internet can be connected by switches only. It's gonna be not scalable, right? A lot of traffic will not be optimal. So that's why we need a routing intelligence for the internet or wide area network. For LAN, it will be administered by one single entity, like UMKC, like some enterprise. Okay. So here, the keyword is first of all set of computers cluster, and then they are connected over LAN. So this is a little old picture, actually indicating that cluster computing has been there for a long time. Like you have heard of parallel computing for a long time. If it's not a one single big supercomputer, it will be all cluster computing. Our university has a few clusters too. And then, myself and other faculty members, when we write a proposal, sometimes it is for equipment for our students, education and research, and that includes this one was, the really for HPC, high performance computing facility to improving it, and that's really about all the cluster computing. So they can perform. Actually, I said that it says the same task. Well, multiple people can do their different tasks together. What I'm saying is that multiple computers can be used to do the same work, right? So for a single purpose, you use more than one servers, computers. That has to then. What about the operating system? More than the hardware orchestration. management control. There should be some software to do that. For this is particularly the compute resource. Really, it's about the CPU scheduling. There are multiple CPUs. There should be managing software. Like our one of the example is called Slurmed. Simple Linux-based the controller for clusters, and that's what actually we use on our current SCE cluster. So that is cluster computing. Do you think cluster computing is important for cloud computing?
Yes.
It's used, do you think? Answer is, of course. Okay. Yeah. So the cluster computing, it is within a data center, there will be racks. It's actually when you have some big task that has to scale up, right? You use more than one virtual machine. You do use cluster computing. But cloud computing is actually bigger than cluster computing. You can tell, right? Because it's not just over LAN, right? So it's one of the core components of the cloud computing technologies. However, there are some distinctions. Cloud computing uses all, but it's for the bigger one. Grid computing. What does grid mean? Where the word grid comes from? What's that?
Electricity grids, like
The
wires
geometric
connecting
shape.
system.
Yeah. Actually, this word comes from power grid. Power grid. So this is a grid, and when we say grid, actually it means power grid. If you look at the power grid, if you hear the news or read articles, energy issue, power grid, power. There are some big power plants, but it has to be distributed, and there are multiple places where the powers are generated. It's a network. Okay, so. That's where the idea is coming from. Power grid is a scale beyond one building, right? It's a state or entire country, right? So this is really geographically big in scale. That's what it means. If you look at just this picture, okay, this is more than one computer connected peer to peer. You may say. The only thing you might think is that, so using more than one computer. But here, the scale is really big. The wiki definition is that combination of computer resources from multiple administrative domains apply to a common task. So again, for a single task, you can use more than one. Then it's same as cluster computing too. Here, big distinction is multiple administrative domain. Cluster computing, is that administered by a multiple domain? No, it's just UMKC network. You have the enterprise network. It's just one single administrative entity. Grid computing, here's a UMKC, and there's a KU, and there's other universities. Maybe multiple universities in different locations. They may have HPCs, right? The clusters, or even single server. Somebody has a server available at their home. Maybe all those can be connected together, used together for single task. So that's the idea of grid computing. Core idea, so it's all parallel computing model. It's really based. It's fundamental here. Parallel computing, how it is done by a single entity within a LAN. That's a cluster computing. And so this is some of them words from Wiki, but you actually can say and can understand beyond what this says. This picture it's not just the it really looks like a peer-to-peer computing server connectivity only, but that's not the point. The point is that geographically dispersed multiple administrative domains resources are used together for a single task like a supercomputer. And when we say, hey, let's do a grid computing for this and for this, it's not like there is a like big internet. This is the grid that everyone can use it for whatever purpose. That's not the case. I mean, the resource has to be administered, managed. So there should be some agreement and special purpose. So that there are things like this computation, and also for that, so there are multiple grids. Let's do this for weather forecasting. The universities or national labs for in physics. Let's put our resources together and do a grid computing. That's an example. And depending on such tasks, sometimes the grid resources are more focused on the CPU power, computational grid, or data. Here's the data from national lab, in East Coast, West Coast, or the South, and so on. So it can be some, and special like NASA, the space related data, or other the data from ocean, things like that. So the special type of data related to grid computing, sometimes resource related one. And there's some project called the multiple project that is basically let's use underutilized resources for a greater good, right? That's a scavenger grid. So from some university, multi-university, there will be a tech lead. Here we do a scavenger gridding. Whoever you have, sleeping underutilized servers, why don't you donate this while we are sleeping? So that's a scavenger grid question.
So I have a question. You said the parallel computing. Is it the same? You said it's the same with the cluster computing?
Parallel computing is a more fundamental concept that is a basis for all of this that we are talking about.
Okay.
So parallel computing is actually can be also for a single server as well. If you have a multi-core machine, unless these parallel resources, multi-cores, are used together for a same, one program, one task, it won't be utilized, right? So there should be the programming for parallel execution support software that enables that. That's a single system parallel computing. And there can be parallel computing for multi systems, and cluster computing, grid computing, all these we are talking about.
Multi-parallel.
Yeah, so parallel computing, like the words indicates, it's the use more than one computer.
Okay.
Cluster computing, yeah, that too, but for a LAN environment.
Thank you.
For grid computing, this is really big distinction between grid versus cluster. It is, beyond LAN, and also, Google is beyond LAN. Google won't be actually related. Google's data center is nothing. It's less related to this. Here, key idea is that multiple administrative domain. Google is just one entity, one company. They can make a single decision without agreeing with others, right? Even though there are people inside, but that's it's a different. Still they can make a single decision, and they have full control of their resources. Here, as I said, multiple universities or multiple national labs in different places, or who had all different independent administration, meaning all the network. It's actually from the networking perspective, the network will be different. Network prefixes are different, right? So still, it can be used together for a single task, and there has been examples like this. Weather prediction, weather modeling. If you think about these applications, this is a very impossible to do it with the single server. So all these, when there is the application purposes are there, how can we do better prediction? Because there are so much data coming from all over, the space, ocean, all different data is coming together. They have to do pre-computation. It's not possible. It's not possible to do single machine. We need to utilize the multiple machine. It cannot be done as a single entity. So that's why those motivations triggered this, the evolution birth of grid computing. There has been a lot of examples: medical, military, basic research, visualization. I mean, there has been examples too. Like if you have the single computer, I mean, visualization. There are some visualization that does need a lot of computing resources, like a big screen that are tiled together in a matrix format, synchronization, segmentation, all those, and especially the computation. That kind of visualization takes a lot of resources, and these are the really examples that enabled the advances of green computing. Medical research, military research, basic research. It means that it really national labs, U.S. national labs, they have been doing it for a long time. In some sense, really high performance computing, the computer science engineering folks really, of course, helped, but the main motivations came from other fields. The high energy physics, weather forecasting, distributed computing. It's really actually more from computer science, the evolution. But as the word says, this is something you have heard of a lot. It means really using more than one node, but it can be distributed over, different places. So from here, you can tell it can be beyond land. So it is like cluster. It is like grid computing. Okay. What are the distributed computing examples you have heard of? I see that I already have these examples. The grid computing, it actually, because of the multi-entity, it does require and multi-administrative domain and big tasks, again, like weather forecast. It does require really prior agreement, the arrangement, things like that. Oftentimes, so those are the applications. In distributed computing, so this is a big difference. You have seen actually a lot of examples. The file transfer,
Torrent.
peer-to-peer.
Torrent.
What's it?
Torrent.
BitTorrent.
Yeah,
Torrent, the file transfer, file sharing systems. Blockchain is also an example of distributed system. The Skype, it's actually, it uses a distributed computing peer-to-peer architecture, the third generation of the peer-to-peer architecture. Now later they bought by Microsoft, but prior to that it was a separate company. They had interesting novel technologies using peer-to-peer the computing. So this is really from the software side. How can this the computing, rather than compute purpose, it's actually these examples really communication. How can some application be achieved through communication of nodes? Okay, so these days most of the big scale applications like Facebook, it's not like one single website UMKC website, you watch the content, you read the content, and there might be a lot of people who are accessing the website together. So you might use a multiple server for like a CNN.com. It's a different from that. Like the that scale, CNN.com actually bigger scale, but it's the Facebook. It's a completely whole different magnitudes of the scale, right? People send, upload, they mostly upload a lot of like pictures, videos, and a lot of people are accessing it together. It cannot be really done by several servers. And the computing architecture, it's really behind it. There's a peer-to-peer technology. So it's the distributed computing again. It is over multi-administrative domain, and it is actually more focused on the software architecture. So these pictures actually, it's from Wiki. It actually tells you rather than distinguishes. It's also similar, right? How can you tell well, you can tell it is more than one server, but in terms of distinctions, or the applications examples, it doesn't tell it exactly just from these kind of pictures, but now you know how it has evolved and what the word is more focusing on. Distributed computing again is really in terms of the systems, it is geographically distributed by under multiple administrative domain. It really focuses on the software architecture to support the big scale applications. So I have already mentioned this.
Excuse me.
Questions?
Yeah, for the corporate company, MNCs and software-based companies, right? Any other, they are using distributed computing or a cluster-based computing.
It really depends. Smaller scale companies would.
I mean,
have
the
a-
larger scale companies
the-
all over the world,
the
Amazon like that.
I mean, if you have they use cloud computing, which is that has a component of the distributed computing.
Yeah,
right?
that's it. Okay, only.
And then under distributed computing, so to the big data centers, multiple place within a data center, they were gonna use a cluster computing technology.
Okay.
So grid computing is a little maybe So it's related to distributed computing in terms of geographic location. But in terms of the software management, it will be less related to cloud computing.
So I have a question again in distributed computing. So the question is like the Amazon company, those Amazon company is also present in India, UK, and US. So
it is distributed computing.
it is distributed computing.
Yeah, but some application might just use one VM in one location.
Okay.
But if some application uses multiple, servers in different location, it uses distributed. Distributed computing doesn't mean that it should be from different administrative domain.
Okay.
So cloud computing, cloud computing uses distributed computing from one company because they can allow users to use multiple resources from different data centers.
Okay.
That's a big
And another question is, so after distribution computing, inside the distributed computing, there is a cluster computing.
It depends
Yes
on
or
the place,
no?
right now.
Yeah,
Yeah.
you can have just a one server from this site, another server for this site, right?
Mm.
But if the application uses a lot of group of clusters in one site, another clusters within the site, then in that application, distributed computing uses cluster computing, but doesn't have to be always that way.
Okay.
So it's either harder to really have a diagram. This is the the cluster computing, and this is not. Oh, actually, I can the one might actually try, but here the focus is that there can be the different approaches or views to look at this computing. Excuse me. And based on that, the name can be different. Questions? So if you think about all of these, think about the application first, right? The grid computing, weather forecasting from multiple organizations, then these things are necessary, right? So when we say grid computing technologies, it is about these, right? Cluster computing technologies, there should be some job management and scheduling, right? Resource management, and it is done by a single entity. So but the job management, scheduling, this is the cluster computing technologies. Grid computing, if you think about how to build this, well, for some application, you are given, I need to find out who has the resource, how much resource, who needs the resource, how much resource, and that kind of management is necessary. The resources will be very diverse, right? The Google data center, initially, even though they started with a Dell server, for example, later these days they have their own hardware, servers, routers. The router part of the connectivity technologies. So it's a less diverse in terms of the hardware, but grid computing hardware will be very diverse. Resources will be very diverse, less cohesive. And distributed job management and scheduling, it is also part of this. So these are the same or similar technologies. Utility computing is actually very different, just a perspective. Looking at computing as a utility, that's what utility computing is about. Again, from Wiki, it says the packaging of computing resources as a metered service similar to a traditional public utility. So this is the not focusing on the technology that enables computing, but it is really how to use these computing resources. What do you think when this idea of utility computing or this word was introduced? Around what time? Around
Grid computing.
grid computing time? Why?
That's when different administrative domains started coming
Oh.
together to say.
Okay. Oh, that's actually an interesting comment that you brought it up. Not grid computing. The way so it's really about who, right? Who are involved, like universities or like national labs. They know, they understand each other, and they are really trying. They are nice to each other, trying to. They know the set of applications already, so it's not really about money, right? It's a meter service. It's actually behind it is so grid computing is like we have to know how much resources available, who has it. That's important, but it's not really about how to charge you because you have used this much, right? That's actually a really important aspect of the utility computing. Right. Any other guesses when the word utility computing was introduced? 2000? 2010? 80s?
1970.
1970s? Why?
Because at that time the computer was using getting
computer.
popularized because how
So
the
80s was the PC boom era,
Yes.
right? So sometime before 70s that
Yeah.
era. So PC is an example where you don't need utility computing again at all. So utility computing, it's really having multiple users using the single resource in mind, right? So that's the utility. PC, um, you don't. I mean, it is for you, dedicated for you. Um, so utility computing actually the concept it doesn't apply to that at all, or very not much, right? My point is that when I ask this question, you can think that it's really early, right? So the 70s is a good guess. The actually early 61 by one of the fathers of computer science, John McCarthy. And don't you think that this is way before the PC boom era? Since you said it,
Yes.
because it's a PC, people have the access to the computing resource. Way before. So in 61, he said that if computers of the kind that I have advocated become the computers of the future, then computing may someday be organized as a public utility, just as the telephone system is public utility. Um, phone system, you pay, subscribe, right? The computer utility could become the basis of the new and important industry. Do you have a goosebump? I really, I feel goosebump when he had this vision at that time. So really, learning about history, it gives people insight. What's going to happen in the future? You are building your insight toward the future. That's how the history can be really, powerful. Question?
So my question is the utility computing, like one computer is used for multiple purposes. It's like that, like
But not. It's also beyond that. That will be it will be metered, um, the and the so utility computing. Here one of the keyword is a metered service. Another thing is that use on demand too, like electricity, right? Water, faucet water. So it's metered, and you pay as you have much used. You use it when you need it. So that's so it's really concept has been there for a long time, but maybe not people. Very little people paid attention to it, but later, when this utility computing has became a reality in a big way, looking back, wow, isn't it amazing? He had the vision of this. Okay, so in terms of the cloud computing, there are a lot of similarities. It is related to grid computing, distributed computing, using computers from different geographic locations. But still, cloud is owned by a single party, at least at this point of time. In the future, it could be different. Resources are all distributed like all of these. But again, cloud computing, at least at the moment, AWS, GCP, Azure, it's a centralized the model, even though physically it's distributed. Right? Who has it's not a multi-administrative domain. So grid, and not always, but most of this distributed computing, it is over multiple administrative domains. Cloud computing is not. So there's similarities and differences. So the cloud computing is relevant to technologies of all of these, plus alpha, not just that, right? The scale, availability, flexibility. So still the cloud computing uses grid computing technologies. but it's not completely under green computing because it's really administrative domain issue. Cluster computing, on the other hand, it's clearly within cloud computing technologies. But often this is a typical disclaimer. Different things can mean different priorities, but for us, the really who have, for us, we see where it has been used, who really evolved these technologies. We can tell, what are the similarities and differences. In other words, there are similarities, but also differences between others and cloud computing. Right? Some people might think a little different. That's for those who have seen all the big picture, like you, like us, now they know what are the similarities. Question? We have phase 2. Let's see how much we can go. Or at least for this class, since we missed the first 10 minutes, I would like to take the quiz at home. Okay, let's do that. So let's go further. The next set of slides is about the just physical data center components. Especially, we're going to talk about the server and storage, more on the server. Later, we're going to look at the network resources. So, cloud computing used by users using different devices, using software, basically browsers and apps. It is over the internet. Data center is the one who does all the work and provide the services through the web. So we have actually talked about the history, but just a little more interesting pictures, right? You may have seen this picture. How many of you have seen at least some of this picture? Okay, many of you. Which one? Apple II, right? And this is I have shown similar picture that has a tape, device, right? Actually, if you look at this is a personal computer, small. You can put it on top of your desk. The older one was big. It's almost like a rack. Right? This is maybe we had a big, these multi devices, stacked together, put together. We had this before, but a little smaller. So I should say mini computer. I keep forgetting this. This is big computer. This is initial computer. ENIAC. If you have watched the movie Hidden Figures, actually the word computers was referring to people. The NASA sending people to moon. There has been a lot of mathematical computations, and people did it before we had a computer, right? We went to moon. The American went to moon, and what was I going to say? So a lot of computation has to be done, trajectory computation, things that, and it was done by people, including women. And that there's a movie called Hidden Figures. They were called computers. And then in the movie later, they actually, in the later part, new computers like this was introduced, the IBM machine. And it was too big to fit it in the room, because in the movie it says, they break the wall door to bring the computers in. It used to be big. And then later it became a little smaller. That's why it's called mini computer. Then workstation. Then PC, very small personal computer. So big, smaller, small, and big again. More data center pictures. This is later we are going to have a guest talk by UMKC data center administrator, and he's going to show pictures whenever we between us. I say, we're gonna, can you give a talk, and can our student visit there? I believe they're gonna do, they do cleaning, because a lot of cables there. This is actually amazingly neat cabling. This is still not bad. This is actually used to be pretty common, even when I teach network architecture. So we have a network center as well, and I let our student to visit our network center. Again, they try to clean up the room before our student did it. It used to be like this, really. And then these days, it has gotten a lot better.
Takes time to arrange all the stuff, right?
It's not just, it takes a lot of time, but it's a big scale. So if you don't organize it well, one of the messages over here is that if you don't organize it well, suppose something didn't work, how can you find where is an error? It's almost impossible, right? Troubleshooting will be very difficult. So this is, they do cabling, sometimes coloring, and they do bundling of the cables together. So there are a lot of hardware inside a data center, servers that has a CPU, main memory, disks, and it will be put together in a rack. They has to be connected by a switch, usually on top. So this is a so-called on the top of the rack there will be so these are clusters. Clusters are connected through a switch. Switches will be connected again by a bigger, capacity switches. So there will be rows of rack-mounted servers. Typically, a lot of servers within a data center. Lots of power is used. Often independent clusters, so more than one clusters. Data center, more pictures. I think I have. Because I did the shared one. Oh, maybe I will update this. What I was going to show is that beginning of last year, I visited Texas Advanced Computing Center (TACC). Texas multiple universities that the computing center supports them, and they have a really almost public cloud scale data center. There are rows of storage units and things like that, and the cooling, heating is a big issue. One of the cooling system they have is oil cooling, and I took a picture of the oil cooling, where the switch is immersed within a mineral oil. So the next time I'm going to show you the picture. So let's talk about what are the components there and some of the architectures used. So a lot of servers, a lot of data storage units, and connecting devices, and there will be cables, and of course power, heating, cooling too. So one of the motivation, there are multiple motivations behind the cloud computing, but one of the motivation the people had is that the visual servers, it has become more and more powerful, but often it's not always utilized, so it's underutilized. That's why the AWS people say that the myth or truth is somewhat is that AWS became into being as an infrastructure service initially is because they had a lot of underutilized resources they provisioned for online selling. So under SLA and good QoS. So we don't want some system to be overly utilized and have a poor performance, not meeting SLA, giving poor quality of service levels, but still under these constraints, it's our hope as an administrator, provider, the system is better utilized. That's important. That's why we want to do sometimes consolidation of servers, doing migration, right? And when the users need it, we want the system to be available, energy to be less used. This number is keep changing because this is also evolving field. But even if some servers are put into idle mode, still it doesn't use a peak power. However, 70% is a pretty 70% of peak power is a pretty large. So this is not my concern directly, but there are of course community of people who are working on that. And how to reduce energy consumption is a big challenge of the data centers. And actually at the time of the cloud computing was introduced, this is really new computing model, but there would be further future computing models as well. So it's not, of course, cloud computing is amazing. There's there's amazing things that we didn't anticipate before, but always we can find that this is not enough for this situation. So new models are being introduced, and we want whatever computing facility to be able to support that new computing models and services. And the earthquakes, flooding, tsunami can happen. That's something we cannot, it's not our own control as a human. So what we can do is that preparing for such kind of disasters, so disaster recovery. All these are the concerns, basic issues, challenges of the data center operators who does the cloud computing. So here too, again, cloud computing is a new model, but that's not the only model. There are new models of computing are always emerging, like edge computing. The IoT computing is emerged later at a later time. So we want to look at the hardware. Let me just do maybe a couple more slides in a hierarchy quickly. Within a server, there will be different components, and they are all connected by a network. So computer is, in fact, it is a network. The main component, CPU, main memory, and the non-volatile long-term storage, connected by the network. This is a little older picture, actually intentionally. So connected. It's a logical picture. Physically, it is a bus topology. If it's not a bus topology, what other topologies do you know?
Ring topology.
Ring topology, okay. Ring is a special type of bus, but it's actually software is different. Very good. Other topology. Star topology. Very good, right? So depending on the software, the upper layer technology would be different, but fundamentally, when we say bus topology, what it means is that shared medium. If one component, say something, meaning use the channel, everyone will hear it as well. In other words, one at a time communication. That's what it is. Even the car, the car area network, or car it's a big network as well. Has a lot of sensors, vehicle, and they are also connected. And it used to be But I think in the future it might evolve because it's evolving so fast. It's a buzz topology. So when we look at the hardware as a software person, what does that mean? That's an important thing. And how to manage it. Here, the bus topology means that it's a sharing. So how to schedule who get to use the channel is important. And here is a CPU. So this will be the last slide for today. So we talked about multi-core, right? The CPU. What's the difference between multi-core and multiprocessor system?
Single CPU is having multiple cores.
Yeah.
Multi-processors will have multiple CPUs.
Right, that's important one. But how the multiprocessor, the core is actually does processing, right? So how multiprocessor versus is different from multi-core system. Say single processor, multi-core, 4-core versus 4 processor. What's the difference?
I studied it.
So a processor consists of cores, right?
Processor.
Has cores.
The processor.
So suppose it's just the processor has just not multi-core. It's a single processor system.
All right.
One processor.
So
So
the task
I-
distribution is like parallel with more cores. Like if you have 4 cores, you can have 4 different processes.
Right, yeah. So the two system, one system with a 4 processor. Yeah, you can leave if you. That's a. The other one, 4 core. So why don't I stop here
Energy
Okay.
optimization.
and figure it out?
There's a lot of energy.
I mean, say the clock speed is all the same, suppose, right? Here, the key is that what is being shared. Okay. Processor, for us to think, we need a short-term memory, right? And that short-term memory, whether it's a shared or on your own, that's the difference. Right? So there is a L2, L1 cache memory. That's actually where the difference is. Right. Okay, so let me stop here for today, and we'll continue on that last time. Oh, there was a student left. Maybe for this section only. I don't know. Maybe he will email me. The code is week 3, WEEE, 3 E's, K3.
Capital W.
I don't remember, but I will check it right now and let you know. So the code is let's do. So access code will be. Okay. This is the access code for today's. Please.
W is
Deadline
capital.
midnight today. Oh, there's one question. I will take out that question that we didn't talk about. Okay.
I have a question.
Yes.
W is capital.
Small, right? Did I say W capital? Yes. Okay, capital. Yeah.
It's
I'm
capital.
gonna change it right now. So that's small.
Okay.
Thank you. And sorry again for being late.
That guy. Nothing happened.